Hello, everyone. Good morning, good afternoon, and good evening. And thank you for joining us for this session as part of Cloud Native Data Management Day 2021. This is a co-located event with KubeCon KubeCon US 2021. So this is October 2021, not May. The topic for today's session is GitOps-based capacity management for Kubernetes clusters. My name is Bhavin Shah. I'm a technical marketing manager with the Cloud Native Business Unit at Pure Storage, which is the Portworx business unit. And to help me talk about this session, I have Ryan Wallner with me. Ryan, you want to quickly introduce yourself?
Sure. My name is Ryan Wallner. Also work here in the Cloud Native Business Unit, or the Portworx Business Unit, as we like to call it at Pure, with Bhavin, and happy to talk to you about GitOps today.
Awesome. So let's get started. Let's just dive deep, to begin with. Before we talk about GitOps, though, I do want to talk about just general storage in Kubernetes. Just talk about like the 101 level first, before we talk about how we can automatically or automate storage capacity management for you. So when it comes to storage in Kubernetes, there are a few constructs that you need to be aware of. And I'm pretty sure since you're watching this session, you might already know those what those are. But for people that are new, you have a storage class. So when we started with Kubernetes, you could manually provision persistent volumes for your applications, or you can dynamically provision them. Dynamically provisioning persistent volumes is kind of the way forward and has been for a while now. To dynamically provision persistent volumes for your applications, administrators or operators can configure storage classes, and these storage classes include details like the provisioner. So in this case, we'll be talking about the Portworx volume, but there are storage provisioners from different vendors like AWS, Azure, Google Cloud, VMware, etc. Each storage vendor will have different parameters that can be included in their storage class definition. So if you look at our documentation side, you can find different parameters like the replication factor. So how many copies of the persistent volume would you like to save on your storage layer? You can also specify additional things like the IO profiles and IO priorities as part of your application, the type of file system you want. Do you want ext4 or you want just XFS? And additional things, one of the key things that we'll highlight in this presentation is the allow volume expansion is true, because if you want to automate volume expansion, our underlying storage class should allow you to do that in the first place. Now, if a developer wants to ask for storage for his or her application or containers, they can just use the persistent volume claim or PVC construct and point to the storage class that is pre-configured by the administrator or by the operator. So on the right, you'll see an example of a simple PVC YAML file. So here we can specify things like the storage class name, which is Postgres pgbench SC. You can specify the access mode. So again, read write once. If you only want one node to have access to the persistent volume, you can have read write many. You can have read write once pod as well, which is the new access mode that was introduced in Kubernetes 1.22. And you can specify the size of the persistent volume claim. So as a developer, this is just a test dev application. So I need like 10 gigs of volume to start with. So instead of creating a ticket, I can just include that in my PVC configuration, and the storage class will dynamically provision a persistent volume of 10 gigs in size on my Portworx storage layer and present that to my container or to my pod. So that was storage in Kubernetes. But then what is GitOps? This is the second question that I wanted to clarify before we dive into how we can put these two things together. So GitOps, when it comes to like the definition, and I've picked these up from the vWorks side because they are the leader in when it comes to GitOps and terminologies around it. So GitOps is an operating model for Kubernetes and other cloud native technologies. It provides a set of best practices that unify the Git deployment management and monitoring for containerized clusters and application. What does this mean? This means that in addition to your application code being stored in Git and you having a CI/CD pipeline, we can do the same thing for our Kubernetes clusters as well. So you can have your YAML files hosted in Git, which can be a single source of truth, but you still need an automation framework around it that helps you take certain actions based on pull requests that are created. So that's like one quick overview of GitOps. It provides a path towards a developer experience for managing applications where end-to-end CI/CD pipelines and Git workflows are applied not just to your application code and development, but also your Kubernetes clusters and the operation side of things as well. So the one product that we'll be focusing on today is Portworx PX Autopilot and how it helps you automate your storage capacity management using the GitOps fundamentals or GitOps principles. PX Autopilot is one amongst the many modules that Portworx has to help you with your Kubernetes storage layer. So we have PX Store, which provides persistent storage for your Kubernetes pods or containers. We have PX Migrate, which helps you move applications between different Kubernetes clusters that might be deployed across different clouds or different on-prem and public cloud environments. We have PXDR, which helps you configure synchronous and asynchronous disaster recovery architectures for your applications running on Kubernetes cluster. We have PX Autopilot, which is what we are talking about in this presentation, and then additional modules around PX Secure, which provides authentication and authorization for your Kubernetes cluster, and PX Backup, which provides a single unified solution for Kubernetes backup and restore for applications running on any infrastructure. So let's talk about PX Autopilot. What is PX Autopilot? PX Autopilot is a rules-based engine that responds to changes from a monitoring source. That's as easy as it gets. So once I configure PX Autopilot on my Kubernetes cluster, it talks to my monitoring source. So this can be Prometheus, if it's a simple installation, or if you're using additional tools like Datadog or Sysdig. Any PX Autopilot can talk to the monitoring source, and for any events that are generated for the metrics that you specify, PX Autopilot allows you to specify if this then that rules. So if and when certain conditions are met, you can configure the actions that need to be taken when those conditions are met. And this is what PX Autopilot provides you across different Kubernetes environments. You can specify these rules called autopilot rules to expand not just your persistent volume, but also your underlying Portworx storage cluster. So when we talk about use cases, PX Autopilot definitely helps me. Like if I started with a 10 gig volume in size, but my application is writing more and more data, I can configure autopilot rules like, okay, if my used capacity reaches the 50 or the 70% mark, automatically double the size of my volume or automatically add 50% more storage to my persistent volume. That's a PX Autopilot rule. In addition to persistent volumes, I can also configure PX Autopilot rules for storage pool capacity management. So let's say I started with a 2 terabyte Portworx storage layer running on VMware Tanzu in this case. If all the applications that are running on top of Portworx are consuming more storage than what was originally defined, PX Autopilot will not only increase the size of the persistent volume, but to make sure that those persistent volumes actually have usable capacity underneath, it will automatically expand the underlying Portworx storage pool as well. And then the last use case is around rebalancing storage. We don't want a specific storage node inside the Portworx cluster to be the one that's serving the most IO. You can have autopilot rules that rebalances your storage across all nodes to ensure that you get the best performance out of the storage layer. So let's talk about the two different methods or ways that you can leverage PX Autopilot. The first one is automated capacity management. This is where PX Autopilot will monitor for any updates from the monitoring source, which can be Prometheus and Datadog or Sysdig. It will measure and predict what changes are needed based on the triggers that it receives, and then it automatically acts. So in this case, if my monitoring source is telling me that my persistent volume is already more than 70% full, PX Autopilot can automatically act and expand the persistent volume without any admin intervention. So this is where, like, you don't, as an operator, you don't have to wake up at like 3 a.m. in the morning to make sure that your application has enough storage capacity. PX Autopilot will automate this for you. And one additional thing that it provides is you can also specify like a max capacity in your Autopilot rule. So you don't want your application to just run away with all the capacity that it can get. You can set a max capacity parameter as well. And the second use case or second workflow is action approvals based capacity management. So automated capacity management is great, but again, you don't want to be in a situation where your application just keeps consuming storage without any admin approval. So if you are an organization that needs to specify these action approvals, PX Autopilot can allow you to do that as well. So now it not just it will monitor and predict your usage, but as soon as it hits that threshold, so let's say your persistent volume is more than 70% full, it will generate an action approval. So it will wait for an admin to approve the expansion requests, either using just kubectl or command line utility, or you can integrate it into your GitOps workflow. So whenever it triggers that rule, a new PR is generated for you in your GitHub repository. You can merge that, you can make those changes, and then PX Autopilot still automates the expansion operation, but it waits for you as the admin to approve that expansion. So with that, let me pass it over to Ryan to do a demo around how you can use PX Autopilot and the GitOps principles to automate storage capacity management. Over to you, Ryan.
All right. So this demo is going to actually showcase the GitOps integration with GitHub. So here we have a Postgres database running in our Kubernetes cluster. We have a single PVC, which is currently at the capacity of 5 gigabytes. It is a read write once volume. And from here, we're going to actually show that we have an autopilot rule already set up that's monitoring this volume so that it can resize the volume. So this shows that it's initialized that volume and it's acting normal, meaning that it's well within its capacity at the moment. So that's what initializing the normal means. Then we're going to drop into this Postgres database itself and start creating some data so that we can trigger this rule. So let's create a demo database and run pgbench on this database. Pgbench will start adding data to this px demo database using the built-in tools. And as it starts adding data, our rule will continuously monitor that volume. And when that rule meets the threshold, Autopilot will trigger that rule. And so when this gets triggered, we should be able to see the next sort of GitOps integration. So here our volume is about 50% full, and our rule should effectively be triggered. I think we set it to at least 30 or 40%. And this may be in production, you may want it to be 70 or 80%, but for this demo, 30 or 40 works. So what we can see here is that it will continue to be initializing to normal and only be triggered after a certain amount of time that the capacity remains true, meaning that Autopilot won't resize it the moment that your capacity is reached, because data gets deleted too from databases. So this has to remain true for, I think, about 30 seconds by default until it gets triggered. So now you can see it's moved from normal to triggered. And this means that Autopilot will start to resize the volume. In this case, we set up action approvals. So Autopilot isn't going to automatically resize your volume. It's going to actually kick off the approval process. And whether you set this up with GitHub or kubectl, that needs to be approved. So here you can see the get action approval command shows the approval state is pending. We have it set up with GitHub. So now it's integrated into our repository where you can see an Autopilot approval waiting in a PR status. And this gets you information exactly on the rule ID, what's it's going to do. It's going to increase the volume from 5 gigabytes to 10 gigabytes on the specific PVC, PG Postgres data. And so as an admin, I can go ahead and merge this as an approval. So this is me approving this rule change as an admin, which is really just merging a PR in GitHub. And now the action approval changes to approved once it gets the feedback from the GitHub repository, and can move on with actually changing the size of the volume. So to confirm that, let's go ahead and look at our PVC. Now says the capacity is 10 gigabytes, where before it started at 5. We can also jump back into our Postgres container and confirm that we are now only at 24% full because we've increased the size. So this is really the power of Autopilot combined with the power of GitOps for your storage capacity management. And many organizations, choose to do it this way and integrate with GitOps, the really powerful tools for Kubernetes. And we're just doing it from the storage capacity side. So that is all we had for this session today. And until next time, thank you very much.